All right, hello everyone. This is MAT0022. This is practice test 1, part 2. We're going to pick up where we left off at number 17, where we're asked to write 9/75 as an equivalent decimal. So we have to divide in order to get that equivalent decimal. We'll divide the bottom number into the top number. So 75 into 9. 75 cannot be divided into 9. So we'd add our decimal point behind the 9 and above the line and add a 0. Now 75 can be divided into 90 one time. We would subtract here 75 minus the 90. We need to borrow, or 90 minus the 75. We need to borrow here because 0, we can't subtract 5 from 0. So we would subtract here, borrowing to get 1 from the 9. We'll replace this with an 8, and the 0 will become 10. So 10 minus 5 will give us 5. 8 minus 7 will give us 1. Add another 0. Now 75 can be divided evenly. We want to divide 75 into 150. And it could be divided evenly 2 times. 2 times 75 gives us 150. All right, so 0.12 or 0.12 would be this equivalent decimal to 9/75. The next example, number 18, we want to write the given fraction in simplest form. That means to reduce the fraction. Find the largest number that you can divide into 6 and 63. You want the number that can be divided evenly without going over. The biggest number you can divide into both 6 and 63 would be 3. And 3 goes in the 6 2 times. That's in your numerator. 3 can be divided into 63 21 times. So 2 over 21 would be the answer for number 18. For number 19, remember your rules for dividing fractions. You want to put your answer in simplest form, but the keep, change, flip method. So we want to keep this first fraction the same. It'll remain 2/5. We'll change our operation from division to multiplication. And then 3/4, we're going to flip that fraction. That'll become 4/3. We're multiplying, but we want to look at our terms that are diagonal to each other to see if we can reduce this fraction, get to the simplest form quicker. Is there a number we can divide into the terms that are diagonal to each other? 4 and 5, no number could be used to reduce those numbers. 2 and 3, we don't have any digits that can be used to reduce 2 and 3. If that happens, then you just multiply the two numerators and denominators together. So numerator times numerator, 2 times 4 would give us 8. In the denominator, 5 times 3 would give us 15. And this is our answer. All right. For number 20, find the unit rate. Again, that's the amount for 1. We have 130 eggs from 26 chickens. So the unit rate would be how many eggs for 1 chicken or per chicken. So we have that 130 eggs that we get from 26 chickens. The unit rate would tell us how many eggs we get from each chicken. Divide 26 into 130 to determine the unit rate. Now 26 can't be divided into 1 or 13. However, we can divide 26 into 130, and it can be divided evenly 5 times. 5 times 26 would give us 130. So the unit rate would be 5 eggs per chicken. 21, a trail is 2,907 miles long. It begins in a city called A and ends in a city called B. Manfred has hiked 2/9 of that trail before, and we want to know how many miles he hiked during that time period. So if the total trail is 2,907 miles, and Manford has already hiked 2/9 of that trail. So let's say we divided this up into ninths: 1/9, 2/9, 3/9, 4/9, 5/9, 6, 7, 8, and then 9/9 would be the whole distance. So if he hiked 2/9 of the trail, to determine how many miles he's hiked, we take 2/9 of 2,907. That word of means that we're multiplying. So we're multiplying 2/9 times 2,907. We changed that 2,907 to a fraction by placing it over 1. Now, if you notice here, we have 2/9, and then we have 2,907 in the numerator, 9 and 1. We still want to look at those terms that are diagonal to each other and see if we can reduce them. Look at the terms that are across from each other and see if we can divide anything into both numbers to get to our simplified answer quicker. Now that 9 and the 2,907 can be reduced. We can divide both of those numbers by 9. 9 will be divided into 9 one time, and 9 will be divided into 2,907 323 times. Now we just multiply across. So our numerator times our numerator, 2 times 323 would be 646. And in the denominator, 1 times 1. That's just 646 over 1. That's just 646. So the number of miles that Manford has hiked is 646 miles. Number 22, write the fraction as a decimal, and if necessary, we're going to round to the nearest hundredth. So 61 divided by 93, we divide 93 into 61. Now 93 cannot be divided into 6 or 61, so we add our decimal point here, add a 0, and then we want to know how many times 93 can be divided into 610. And that'll be 6 times. Now 6 times 93 would give us 558. We want to subtract, so we're subtracting 610 minus the 558, we should get 52. Carry down our 0. Now 93 can be divided into 520 5 times. And 5 times 93 would give us 465. We would subtract 520 minus 465, we'll get 55. Carry down our 0. And now 93 can be divided into 550. Remember, 5 times 93 gave us 465. 6 times 93 gave us 558. That's still a little too big, so we'll put the 5 again. 465. We want to subtract. All right, but we notice we have 3 digits here. We actually could stop at this point. We're rounding our answer to the nearest hundredth place. That's 2 places after the decimal point. So this 0.655, 2 places after the decimal point, will be the second, or the 5 that's next to the 6. Now the 5, our neighbor, is higher. We have 5 or higher, which means we need to round up. So we round this 5 up to 6. To round it to the hundredth place, we will write our answer as 0.66. Now for number 23, we have 140% of 400 is what number? We're going to use this percent formula for all these questions. Is over of equals percent over 100. So notice here our is, we don't know. So that's going to be our x. The of is 400 and the percent is 140. So where of is the denominator of the first fraction, we're going to replace that space with 400. The is we don't know, so we'll put an x there. And on the right side of the equal sign, our percent is 140. It should be in the numerator. And 100 stays in the denominator on the right. We want to cross multiply to solve. So multiply the terms that are diagonal to each other. So we're multiplying 400 times 140 and 100 times x. So 100 times x gives us 100x equals 400 times 140, which gives us 56,000. To solve this equation, we would divide both sides by 100. And we'll get 560. So 140% of 400 is 560. All right, let's look at number 24, and this will be the last example that we do from the practice test. A plant for a tea company is bagging machines capable of bagging 1,000 bags of tea per minute. So 1,000 bags of tea per minute. 1,000 bags per 1 minute. If a plant runs 22 hours a day, how many tea bags are produced in that day? So if we're bagging 1,000 bags every minute for 22 hours a day, we first need to figure out how many minutes there are in a day. Or excuse me, how many minutes there are in an hour. We know that there are 60 minutes in an hour. So if we have 1,000 bags per minute, we multiply that times 60, that'll give us the number of bags in an hour. To convert the hours then to days, we will multiply the 60 times 24, since we know that there are 24 hours in a day. However, not just 1 hour is that machine running, it's running 22 hours. So we would also multiply that product times 24. All right, so we got 1,000 bags per minute. To convert from minutes to hours, we will multiply that 1,000 times 60. To convert those hours to days, we know that each hour, we have 24 hours in one day. And then to convert the days to 22, to convert those hours actually, because we said 1 minute, 1,000 bags per minute, there are 60 minutes in an hour, so this would get us at hours. And now we actually just need to multiply by 22. So we don't need this extra 24 in here. We were multiplying those 22 hours in a day. Let me erase that number, sorry guys. That will give us 22, multiply all these numbers together is what we want to do. So you're multiplying the 1,000 bags per minute times the 60 minutes in an hour times the 22 hours in a day. And you should get 1,320,000. So 1,320,000 20,000 tea bags in 1 day of operation. All right, so that concludes our review for test 1. To practice more, use the practice 1 test that's in your math lab, and if you have additional questions, send me an email.